All right, so let's get started in Chapter 3, Numbers in the Real World. And the first thing we're going to look at are the uses and abuses of percentages. So let's see. A couple of ways we can use percentages. Actually, there's three we're going to discuss. We can use them to compare two quantities. A percentage is just a fraction of the total. And we can also use them to describe change. So consider the following statements. A total of 13,000 newspaper employees, 2.6% of the workforce, lost their jobs. So let me state that over. A total of 13,000 newspaper employees, 2.6% of the workforce, lost their job. The next statement, Citigroup stock fell 15% last week. And the next statement, the advanced battery lasts 125% longer than the standard one, but cost 200% more. So given those three statements, I want you to figure out which one of those represents a comparison of two quantities, which one represents a fraction of the total, and which one represents a description of change. So looking at the first statement, a total of 13,000 newspaper employees, 2.6% of the workforce, lost their job. That's a percentage of the total or a fraction of the total. So that's one way we can use percentages. That's number 2 above, fraction of the total. What about Citigroup stock fell 15% last week? That's describing a change. What happened with Citigroup stock? Well, we refer to that as a change. It fell 15% last week. So that would be number 3, describing a change. And the advanced battery lasts 125% longer than the standard one, but costs 200% more. That's a comparison of two quantities. So that would be number 1. So different ways we can use percentages, but always keep in mind that a percentage, the word per means to divide, so a percent means per 100 or divided by 100. So if we're given p%, that just means it's that value of p divided by 100. So 35% means the same thing as 35 divided by 100. All right, so let's take a look at example 1. We're going back to that workforce situation, and we've got the 13,000 newspaper employees that lost their job, and that 13,000 represents 2.6% of the workforce. The question is, how big was the workforce, where 2.6% of that number was 13,000 employees? So I'm going to set up a little algebraic thing to work on this. So I'm wanting to find out what the workforce is. How many people were there to begin with, and we lost 13,000 of those. Now think about this algebraically. First, 2.6% is the same thing. If I convert that to a decimal, I move it 2 places to the left. That's 0.026. So 0.026, the word of means to multiply, so it's times. The workforce is what I'm trying to find, so I'll just call that workforce. And 2.6% of that workforce was 13,000 employees. Algebraically, I could solve this equation, set up a simple equation, by dividing both sides by 0.026. To undo the multiplication, we divide. So dividing both sides by 0.026, I get workforce, which is what I'm trying to solve for, by itself. And if I divide those two numbers out, I come up with 500,000 people, because workforce is obviously people. And you can always go back and check your work. Find out what 2.6% is of 500,000, and it should give you 13,000. So let's check out example 2. An opinion poll finds that 64% of 1,069 people surveyed said that the president is doing a good job. So, how many said the president is doing a good job? Thinking about this algebraically, I've got 64% of means multiplication, 1069. 64% of 1,069 would say or said that the president is doing a good job. So this is just a multiplication. It's not a division or set up an equation. We really kind of are setting up an equation because 64% of 1,069 are the number of people that said the president is doing a good job. So make that calculation. It's 0.64 times 1,069. Now, when we get results, they need to be in the context of that particular problem. 64% of 1,069 is 684.16, but these are people. And when we're dealing with people, we don't want to have a portion of a person. So we have to make sure that we round this to a nice whole number. So I would round this to 684 people. So let's look at using percentages to describe change. We have two formulas here that we're going to use to describe absolute and relative change. Now remember, I'll give you formulas on the test. You just need to be able to know how to use them. So absolute change, when you're looking at two quantities and you want to see how they change, you've got a new value and a reference value. All you have to do is subtract them. Find the difference in those values, and that'll tell you how it changed. Like the temperature this morning was 77 degrees. The temperature this afternoon was 97 degrees. What is the absolute change? Well, it changed by 20 degrees. If I subtract 97 degrees minus 77 degrees, the absolute change was 20 degrees. Now, what if I wanted to find the relative change? That's going to be a percentage. So I would take that absolute change of 97 degrees minus 77 degrees, and I would divide that by the reference value, which would be the 77 degrees, multiply it by 100 to get a percentage. Again, I'm going to give you these formulas. You just need to be able to use them. So it's the new value minus the reference value divided by the reference value. So it's the absolute change we found earlier divided by the reference value. And if I multiply that by 100%, that'll give me a percentage. So if I took my example with the temperature, the new value was 97 degrees in the afternoon. The reference value was 77 degrees for the morning. Then I would divide that value by 77 degrees and multiply that by 100% to give me a percentage. So figure that out. So as a percentage, this would be 25.97 degrees, and it's as a percent, so we write percent behind it. So what that number tells me is that the degrees, the temperature changed by 25.97%. Actually, I don't need the degree on that. It's 25.97%. So that was the change. It was an increase by 25%. Or 25, we could round that off. We'll call that 26%. Okay, so given that example, let's look at example 3. The number of students enrolled in a university in the fall of 2000 was 12,090 students. In the fall of 2013, the enrollment was 14,590 students. So find the absolute and relative change. It's important to realize which one is the new value and which one is the reference value. And when you're working with time, it's pretty obvious. The 14,590 is the new value, and the 12,090 students is the reference value. And so the absolute change is the new value minus the reference value. Well, the new value is 14,590 students. The reference value is 12,090 students. and just subtract that, and that gives us the absolute change. And to find the relative change, it's that new value minus the reference value divided by the reference value, but we're going to multiply it by 100 to get a percentage. So the absolute change comes up to be 2,500, and the relative change ends up being 2,500 divided by 12,090, and we multiply that by 100 to get us a percentage, and it comes up to be 20.67%, and maybe we could just round that to 21%. So how do we interpret that 21%? That means it's interpreted as there was an increase in enrollment by 21%. So you set up example 4, work it as we did example 3, pause the video, work it out, and then turn the video back on and see if your interpretation is correct. Working example 4, the absolute change is $300, which is our new value, minus $150, which is our reference value, comes up to be $150. Now the relative change will be that value, 300 minus 150, divided by the reference value, which is 150, and multiply that by 100, and we end up with 100%. So that tells me the price of a 4-star meal has increased by 100%. Notice that the price doubled. So you could kind of say, well, if the price or the value, I won't put price, I'll put if the value doubles, then that's interpreted as an increase of 100%. It increased by 100%. What if the value of something tripled? If a value triples, then that means it has an increase of 200%. It means it's the original plus twice the original. And so on. You kind of see a pattern here. If it quadrupled, if a value quadruples, then that's an increase of 300% because it's the original plus 3 times the original. So we can fill out these two values. When it triples in value, it increases by 200%. When it quadruples in value, it increases by 300%. Now set up and work problem 5, finding the absolute and relative change. Pause the computer, and once you have your values, turn it back on and see if your values are correct. First thing you need to do is recognize which value is the reference value and which value is the new value. So when I read this, it says I bought a computer 3 years ago for $1,000. Well, that's going to be my reference value, thinking about time. Today, it's worth $300. That's my new value. So once I've decided and made that decision about the new value and the reference value, I just need to plug those into the formula. So the absolute change is new value minus reference value. 300 minus 1,000, we get negative 700. Relative change is that new value minus the reference value over the reference value, and we multiply that by 100 to get us a percentage. When we do that, we get a negative 70%. How do we interpret that? Okay, so I get a negative percentage. What does that tell me about the worth of my computer? Has its value increased or has its value decreased? Obviously, it's decreased, and it's decreased by 70%. So we would interpret that value as a decrease in value by 70%. So that you will get negative values, but we interpret those negative values as a decrease. think I will stop the first part of this video here, and then I will pick up with section 3A part 2 next. So I'll stop this one here.